Yes. Good evening, all of you. Okay, so let us continue the MCQs from this chapter, that is electromagnetic induction. Okay, so last lecture में हमने कुछ MCQs already देखे थे. So let us see some more MCQs of the same type based on the same chapter. Okay, so I hope you can see the screen. This was the last question we have done last time. Okay, let us see the next. Okay, the seventh question we had last time. Let's see some questions from last year exams. ये सेकेंड वाला क्वेश्चन तुम कर सकते हो खुद से, ठीक है नहीं? It's very easy. We have already done this type of question in previous lectures. A coil has 1000 turns, 500 centimeters square as its area. The plane of coil is placed perpendicular to the magnetic induction of 2 into 10 raised to minus 5 Weber per meter square. The coil is rotated through 180 degree in 0.2 seconds. तब देखो, जब कॉइल 180 डिग्री से रोटेट किया जाता है तो उससे क्या होता है कि फ्लक्स जो पहले फॉरवर्ड डायरेक्शन में था तो वो अभी फ्लक्स जो है वो अपोजिट हो जाता है, मतलब नेगेटिव कहलाता है. तो जब फ्लक्स पहले पॉजिटिव था और नेगेटिव हो गया तो द चेंज इन फ्लक्स विल एक्चुअली बी कंसिडर्ड टू बी डबल whatever is the passing flux passing through that coil initially, उसका डबल ये रहेगा चेंज. और वो चेंज कितने टाइम में होता है वो भी टाइम दिया हुआ है ऑलरेडी. तो d5/dt यूज करके हम आराम से इंड्यूस्ड ईएमएफ निकाल सकते हैं यहाँ पे. बिल्कुल. ये थर्ड वाला क्वेश्चन भी हम देख सकते हैं. अ लॉन्ग स्ट्रेट वायर कैरिंग करंट ऑफ 30 एम्पियर is placed in external uniform magnetic field of induction 4 into 10 raised to minus 4 Tesla. The magnetic field is acting parallel to the direction of current. Then the magnitude of the resultant magnetic induction in Tesla at a point 2.0 centimeter away from the wire is. Okay, this requires some discussion. So let us take it on your board. Okay, so let us read this question once again and try to draw the diagram based on the yes. Okay, so see here, a long straight wire carrying the current 30 ampere is placed in a external uniform magnetic field. Okay, so wire can be shown by the red colored arrow like this. Okay, which is placed here, and it carries the current of 30 ampere. Okay, yes, this is the wire, and it is placed in a uniform magnetic field of induction 4 into 10 raised to minus 4 Tesla. The magnetic field is acting parallel to the direction of current. Okay, so where can we show the magnetic field here? See, the magnetic field can be shown to be directed upwards here. Let us draw it by the blue colored arrows in this way. Okay, so this is the magnetic field here. Yes. Now the magnitude of resultant magnetic induction in Tesla at a point which is 2.0 centimeter away from the wire. Yes, that means there is a point which is at a distance of 0.2 centimeter from the wire. That means suppose it is this point here. ये वाला point है यहाँ पे, जहाँ पे जिसका distance 0.2 सेंटीमीटर है इस वायर से. तो इस पॉइंट के ऊपर का रिजल्टेंट मैग्नेटिक इंडक्शन हमको ढूंढ के निकालना है. अब देखो, अगर हम राइट हैंड रूल यूज करेंगे तो रेड कलर के डायरेक्शन में करंट फ्लो हो रहा है, तो उस डायरेक्शन में अगर हम हमारा थंब अगर अरेंज करेंगे तो फिंगर्स जो है, कर्ल फिंगर्स, वो इनवर्ट डायरेक्शन रिप्रेजेंट करते हैं, which is actually going to be the magnetic induction just produced due to the electric current here at the point. तो इस पॉइंट पे मैग्नेटिक इंडक्शन जो है वो करंट की वजह से प्रोड्यूस होने वाला जो मैग्नेटिक इंडक्शन है, तो वो एक्चुअली अंदर के डायरेक्शन में रहेगा. ठीक है, वी कैन जस्ट शो इट इन दिस डायरेक्शन हियर. दिस इज द डायरेक्शन ऑफ मैग्नेटिक इंडक्शन. यस, but at the same time at this point the magnetic induction due to the external magnetic field will actually be directed in the upward direction because already वो upward direction में है ही यहाँ पे. ये तो ये जो मैग्नेटिक इंडक्शन है वो अपवर्ड डायरेक्शन में रहेगा. अब देखो इनके बीच में कितना एंगल है, 90 डिग्री का एंगल है. भले हमको वहां पे उसको दिख नहीं रहा वैसे, लेकिन वी कैन जस्ट ड्रॉ इट लाइक दिस. ठीक है, इट इज एक्चुअली इनवर्ड्स. ये जो रेड कलर वाला जो एरो है वो एक्चुअली अंदर की तरफ है, इसलिए हमको वो थोड़ा सा इमेजिन करना पड़ेगा. बट दिस एंगल इज गोइंग टू बी 90 डिग्री, एक्चुअली अंदर की तरफ है. ठीक है ना, तो इसलिए इन दोनों के बीच में 90 डिग्री एंगल है. तो इनका जो रिजल्टेंट है, तो वो रिजल्टेंट कौन से डायरेक्शन में जाएगा, जरूर उनके द्वारा फॉर्म किए हुए पैरेललोग्राम के डायरेक्शन में जाएगा जरूर. तो ये पैराग्राम जो है वो हमको ड्रॉ करना होगा और इसका रिजल्टेंट जो है वो हमको ढूंढ के निकालना होगा. सो जो दो वेक्टर्स, इसको हम बोल देंगे सपोज चाहिए तो B1 और B2. B1 मतलब मैग्नेटिक इंडक्शन प्रोड्यूस ड्यू टू द करंट, ओके, एंड B2 इज द मैग्नेटिक इंडक्शन प्रोड्यूस ड्यू टू द एक्सटर्नल मैग्नेटिक फील्ड, ओके, जो कि डायरेक्टली दिया हुआ है. ये 4 × 10⁻⁴ जो है ना वो एक्चुअली B2 ही दिया हुआ है. Okay, so B1 and B2, B1 can be found out by using the formula for magnetic induction due to the straight current carrying conductor, which is given by the formula mu naught I upon 2 pi A or 2 pi R, which we already studied in the last chapter or last to last chapter, that is magnetic effect, magnetic fields due to electric currents. तो यहाँ पे mu naught का जो वैल्यू है वो हमको ऑलरेडी पता है, it is 4 pi into 10⁻⁷, and that is multiplied with current which is 30 ampere here, and that is to be divided by 2 pi into R, where R is going to be the distance of that point from the center of the element of the current. तो जो कि 0.2 नहीं है, वो 2.0 है एक्चुअली. यस, दिस 0.2 इज नॉट देयर, 2.0 मतलब 2 ही हो गया वो, तो 2 सेंटीमीटर, लेकिन सेंटीमीटर को मीटर में कन्वर्ट करेंगे तो वो 10⁻² वहां पे आ जाएगा. तो यहाँ से ये 2 पाई इंटू 2 मतलब 4 पाई बनता है, और ये 4 पाई कैंसिल हो जाएगा और बाकी बचेगा 30 इंटू 10⁻⁷ प्लस 2 मतलब 10⁻⁵ हो गया वो. सो वी कैन जस्ट गेट दिस एज 3 इंटू 10⁻⁴ टेस्ला एज अ फाइनल आंसर. ओके, नहीं सॉरी, दिस इज द B1 ओनली. ये तो हमने अभी तक B1 निकालना है. अभी B1 तो चलो मिल गया. B2 का क्या है? सो B2 इज ऑलरेडी देयर. B2 इज गोइंग टू बी 4 into 10⁻⁴ टेस्ला. ओके, तो B2 भी हमारे पास है. अभी हमको B निकालना है जो कि इन दोनों का रिजल्टेंट है. देखो, तो रिजल्टेंट B कैन एक्चुअली बी फाउंड आउट बाय यूजिंग द पैरेललोग्राम लॉ ऑफ वेक्टर एडिशन, वेयर B is going to be the resultant and it is equal to root of B1 square plus B2 square plus 2B1 B2 into cos theta, where theta is actually going to be 90 here, and since cos 90 is 0, this third term it's of no use, and we can just be left with these two terms only. and get this as root of b1 square plus b2 square. That's all. बट यहाँ पे b1 और b2 इन दोनों के अंदर ऑलरेडी 10⁻⁴ इंक्लूडेड है. ये देखो, ये 10⁻⁴ इधर भी है और इधर भी है, तो जरूर हम 10⁻⁴ को सीधा बाहर ले लेंगे. यहाँ पे स्क्वायर रूट के भी बाहर ले लेंगे और सीधा स्क्वायर रूट के अंदर क्या आएगा, सिंपली 3 का स्क्वायर और 4 का स्क्वायर. बस अभी वो तो हमको ऑलरेडी पता है कि 3 का स्क्वायर 9 प्लस 4 का स्क्वायर 16, तो 9 plus 16 बनता है 25 और root of 25 is 5. So we can just write this as, say, finally 5 into 10⁻⁴ Tesla, which is going to be there in the option 3 here. Okay. Yes. Just take a screenshot if you want. Okay, can you do this 8th one? Actually, 8th one is not based on this chapter actually. वो भी उसी चैप्टर पे बेस्ड है. Yes, let us read the question carefully. Two ions having equal masses but charges in the ratio 1:2 are projected perpendicular to a uniform magnetic field with the speeds in the ratio 2:3. The ratio of radii of circular paths along which these ions move is. Okay, so see here the ratio of radius of circular path. So radius of circular path when a charge is fired into a magnetic field is given by the formula mv upon qb. If you remember, this we already derived in last lectures also, using centripetal force equal to the magnetic force. तो अगर ये हम यहाँ पे यूज करेंगे तो R1 के लिए फॉर्मूला क्या बनेगा, इक्वल मासेस. तो मतलब मासेस के बारे में हमको M1 M2 बोलने की जरूरत नहीं है, ठीक है, बट चार्जेस के बारे में Q1 Q2 बोलना पड़ेगा और स्पीड्स को भी हमको V1 V2 बोलना पड़ेगा. सो लेट अस टेक दिस एज M into V1 upon Q1 into magnetic induction is going to be the same because same magnetic field के अंदर वो प्रोजेक्ट किए जा रहे हैं. And R2 can be written to be simply equal to M into V2 upon Q2 into B, right? So if we just consider this as equation number 1 and this as equation number 2, then we can just take the ratio of these two equations R1 upon R2 and get that this MM will get cancelled, BB will get cancelled, and here we can just be left with V1 upon V2 into Q2 upon Q1. Okay, तो वेलोसिटीज का जो रेशियो है वो उल्टा आएगा और चार्ज का रेशियो उल्टा हो जाएगा. तो वेलोसिटीज का रेशियो कितना है हमको यहाँ पे पता है ऑलरेडी, 2:3 है, राइट? So just keep it as it is and reverse the ratio of charges which is given to be 1:2 here. So उसका उल्टा क्या हो जाएगा, 2:1 हो जाएगा, right? So you can just get this as 4:3. So 4:3 is actually going to be the ratio of radii in which these two charges will move in the magnetic field. Yes, let us see the next. ये जो है 13th वाला बहुत इजी है, देखो। अच्छा, आई विल जस्ट टेल यू हाउ टू डू ऑल दिस सम्स, दे आर वेरी सिंपल एक्चुअली। ये देखो 11th वाला सम जो है वो देख सकते हो आराम से। एक सिंपल सी बात है, a circular coil of radius 2r is carrying the current I. The ratio of magnetic field at the center to the magnetic field at the distance 6r from the center along the axis of the coil is, तो मतलब हमको सिंपली कॉइल के सेंटर पे मैग्नेटिक इंडक्शन और उस कॉइल के एक्सियल पॉइंट पे 6r डिस्टेंस पे रहने वाला मैग्नेटिक फील्ड, इन दोनों का रेशियो निकाल के दिखाना है। और दोनों के लिए हमारे पास रेडीमेड फॉर्मूले है, अगर आपको चाहिए तो ये करके भी देख सकते हैं। देखो यहाँ पे, just try to draw the diagram. It will be just like this, in which the circular coil will be of radius 2r. Suppose this is the circular coil, and the radius of the circular coil is going to be 2r here. Okay, and this is the axis of the circular coil, and this is the point which is at a distance of 6r from the center, where we have to find out the magnetic induction and compare it with this magnetic induction at the center. So magnetic induction at the center can be considered as B naught, and the magnetic induction at the point P, which will be considered as B here. So B naught के लिए तो हमारे पास सीधा फॉर्मूला है, the magnetic induction at the center of a current carrying coil is actually given by mu naught I upon 2r, correct है? But radius of the coil is 2r, so therefore it will be 2 times of 2r. मतलब ये बन गया actually mu naught I upon 4r, correct है? And number of turns तो चलो सेम ही होंगे, तो उससे वो कैंसिल हो जाएगा। वैसे तो कुछ दिया नहीं नंबर ऑफ टर्न्स के बारे में, बट चलो ठीक है। So यहाँ पे B will be actually the magnetic induction at a point at a distance x from the center is actually along the axis is actually given by the formula mu naught into I into r square, okay, r square, and that is to be divided by 2 times of r square plus x square the whole raised to 3 by 2, okay. So this is actually going to be the formula. Okay, so if we just use this formula here and just put this x as 6r here, तो yes x का वैल्यू ही यहाँ पे 6r दिया हुआ है, तो वो अगर हम यहाँ पे डाल देंगे ना, तो यहाँ पे हमको मिल जाएगा म्यू नॉट इंटू आई इंटू आर स्क्वायर, बट r is here going to be 2r, right? So radius of the coil is going to be 2r, so उसका स्क्वायर हमको करना पड़ेगा यहाँ पे, एंड डिनोमिनेटर में क्या आएगा देखो ठीक से, so 2 टाइम्स ऑफ ब्रैकेट में आएगा r स्क्वायर, sorry 2r square, क्योंकि radius of coil is going to be 2r here, so 2r square plus x is actually going to be 6r here, and hence 6r का square और उसका whole raised to 3 by 2, which is kept as it is. And then we can just solve this further and get this mu naught I into, here it will be 4r square actually, which is to be divided by, here it is 2 kept as it is, and here it is 2r square becomes 4r square, right? So here it will be 4r square plus 6r square comes out to be 36r square, okay, and the whole raised to 3 by 2 is kept as it is. So actually this happens to be 40r square, right? So we can just have this as mu naught into I into 4r square, which is to be divided by 2 times of 40r square और उसका whole raised to 3 by 2, okay. And then we can just simplify this further and get this B to be simply equal to mu naught, okay, we can just write it as 4 mu naught I into r square, which is to be divided by, here it is 2 is just kept as it is, and here it will be, or just let us cancel it out, cancel this 2 and 4 out. यहाँ पे हम क्या करेंगे, 4 को और 2 को कैंसिल कर देंगे, ये 2 जो है वो इस 4 के साथ कैंसिल होके 2 बचेगा. So finally we can just say that this B will be actually equal to 2 times of mu naught I r square, that is to be divided by, here it comes out to be 40 raised to 3 by 2 and r square raised to 3 by 2. So just keep it as it is, 40 raised to 3 by 2 into r square the whole raised to 3 by 2 as it is, okay. And now if we just simplify this further, then we get this mu naught into 2 into I into r square, and that is to be divided by here 40 raised to 3 by 2 का मतलब क्या होता है 40 का क्यूब और उसका स्क्वायर रूट. So we can also write it as square root of 40 and उसका cube. So if you just write this square root of 40 and उसका cube as it is, and here r square का raised to 3 by 2 क्या बनेगा, ये 2 cancel हो जाएगा और बचेगा simply r cube, right? And then we can just get this as r square cancel, leaving behind r in the denominator, and here it will be 2 times of mu naught I upon, here it is going to be root of 40 can actually be written as okay, so 2 mu naught I into upon root of 40 can be actually written as 40 can be written as 4 into 10, right? So 4 का square root बनता है 2, so it can be written as 2 root 10 here, and 2 root 10 का cube and r kept as it is, so that we can just get this 2 mu naught I upon, here it is going to be 2 का cube जो कि बनता है 8, और यहाँ पे 10 root 10 का cube मतलब 10 root 10, right? So here it is going to be 10 root 10 into r as it is. Okay, so this is actually b here. What we want here is the ratio of the magnetic field at center to the magnetic field at a distance 6r, मतलब हमको निकालना है b naught upon b, ये रेशियो करेक्ट है. तो b naught upon b अगर निकालना है तो b naught का वैल्यू क्या है हमको पता है ऑलरेडी, it is mu naught I upon 4r, right? And what is the value of b here? It is going to be actually 2 mu naught I upon 80 root 10 into r. Okay, so here it can be said that since that this mu naught I and r can be straight away cancelled. Okay, बाकी जो बचेगा उसको अगर हम as it is लिख देंगे यहाँ पे तो 1/4 kept as it is, and the reciprocal of this whole thing will just be expressed as 80 root 10 upon 2. Okay, so that we can just get this 4 into 2 8, so that we this 80 के साथ इसको कैंसिल करके यहाँ पे सिर्फ 10 बचेगा. So finally हमको मिलेगा simply 10 root 10, that's it. Okay, 10 root 10, that means this 2 is going to be actually the correct option here. Yes, see the next one. Okay, ये 12th वाला भी बहुत इजी है, तुम खुद से कर सकते हो. देखो, a magnetic field of 500 microweber passing through the 200 turns coil is reversed in 20 milliseconds. The average EMF induced in the coil is, again the same thing, flux reverse हो गया मतलब change in flux double हो गया. ठीक है, so just find out the initial flux and just double it and just take it as a change in flux and just divide it by the time in seconds and then get the induced EMF in it. That's it. 13th वाला देखो, 2 parallel rails of railway track insulated from each other and with the ground are connected to millivoltmeter. Okay, 2 रेल ट्रैक्स है जो इंसुलेटेड है एक दूसरे से और ग्राउंड से भी, और वो मिलीवोल्टमीटर के साथ कनेक्टेड है. ठीक है, द डिस्टेंस बिटवीन दीज 2 रेल्स इज 1 मीटर. ओके, द ट्रेन इज ट्रैवलिंग विद अ वेलोसिटी ऑफ 72 किलोमीटर पर आवर along the track. Then reading of millivoltmeter is vertical component of Earth's magnetic induction is already given to be 2 into 10 raised to minus 5 Tesla here. Okay, so see here. Can you tell me what formula should we use here? कौन सा formula यहाँ पे use करने लायक है, कौन बताएगा? Just put it in the chat box or just unmute your mic and tell me fast. Yes, anyone? कौन सा formula हमको use करना पड़ेगा यहाँ पे? Yes, see here. Suppose there are 2 rail tracks. We can just draw them. here in the diagram. Suppose ये दो rail tracks है. Okay, this is the first rail track. And this is another one. Okay, and they are parallel to each other and they are just connected with a millivoltmeter. Okay, यहाँ पे एक millivoltmeter यहाँ पे connected है. Okay, suppose this is the millivoltmeter which is connected between these two rail tracks here. Okay. Yes, and then suppose train, ठीक है, एक train जो है तो वो traveling with a velocity of 72 km/h along the track. अभी देखो अगर ट्रेन दौड़ेगा तो यहाँ पे उसके जो व्हील्स है तो व्हील्स भी इसके ऊपर से दौड़ेंगे जरूर. You can just show these wheels like this here. Suppose this is the first wheel and this is suppose the second wheel. दिख रहा है ठीक से? Okay, and these two wheels are actually connected by a rod. जैसा कि हम जानते हैं रेल्स के अंदर, ट्रेन के अंदर जो व्हील्स है तो वो दोनों व्हील्स यहाँ पे एक रॉड के द्वारा कनेक्टेड होते हैं इस तरह से. ये देखो ऐसे. Yes, like this. Okay, so when these wheels will just move at a horizontal direction, at a speed of 72 km/h, then this rod will also just move in the same direction with the same speed, right? 72 km/h. Okay, and at the same time, it will actually be cutting the vertical component of Earth's magnetic field, which is already there. तो यहाँ पे ये जो अर्थ का मैग्नेटिक फील्ड का जो वर्टिकल कंपोनेंट है which can be drawn here in the downward direction in this case. तो ये जो है this is the vertical component of Earth's magnetic field which can be drawn in the downward direction here. Okay, and it is denoted by BV. Okay, तो ये अर्थ मैग्नेटिक फील्ड है जिस उसका वर्टिकल कंपोनेंट है जो कि डाउनवर्ड डायरेक्शन में काम कर रहा है. Yes, अभी ये हमको ऑलरेडी पता है कि whenever rod just moves in a magnetic field perpendicular to it, there is a induced EMF produced in that rod, correct? And that induced EMF is actually given by the formula E is equal to B into L into V, correct? So if we use it here, then the magnetic induction, the vertical component of Earth's magnetic induction is given already to be 2 into 10 raised to minus 5 Tesla, which is kept as it is. The length of the rod is actually going to be 1 meter because it is already given that the railway track, the distance between two rails is going to be 1 meter. Okay, ये यहाँ पे दिया हुआ है देखो. The distance between two rail tracks is 1 meter. So यहाँ पे हमको 1 meter डालना होगा, which will be the length of that axle, and v is the velocity. तो हमको पता है ऑलरेडी उसको 5/18 से मल्टीप्लाई करना पड़ता है, करेक्ट है? सो हियर 18 1s are 18 4s are, so it comes out to be 20 meter per second actually. So here 20 has to be put here, and then we can just be able to multiply this as so as to get 40, and this 40 into 10 raised to minus 5. If you just want to make it in millivolt, तो उसको हम लिखेंगे 0.40 into 10 raised to minus 3 volt, which actually can be written as 0.4 millivolt. Okay, so and this is millivoltmeter only. तो millivoltmeter के अंदर रीडिंग कितना आएगा फिर? Obviously 0.4 millivolt, इतना रीडिंग उसके अंदर आएगा जरूर. Okay. Yes. Let us see the next one here. Can we do this 16th one here? It's again very easy actually. See, the proton is projected with the velocity of 10 raised to 7 meter per second at right angles to a uniform magnetic field of induction 100 millitesla. Okay, so there is a uniform magnetic field produced in the space. Okay, so this is the electric magnetic field. Okay, this is the magnetic field which is produced in the space, and the proton is projected with a speed of 10 raised to 7 meter per second at right angles to this uniform magnetic field of induction. It is given the time the proton to traverse 90-degree arc is okay. So see here 90-degree arc इस प्रोटॉन को ट्रेवल करना है. तो सबसे पहले ये बात है कि ये प्रोटॉन जो है वो सपोज इस डायरेक्शन में एंटर करता है. ठीक है, सपोज protons in this magnetic field in this direction here. Okay, with the speed v, obviously. So what happens, as soon as it enters into the magnetic field, it will just start experiencing magnetic force. So that magnetic force will be given the right hand rule. तो right hand rule भी आप ये यूज करना है. Velocity जो है वो इस डायरेक्शन में है और मैग्नेटिक इंडक्शन इनवर्ड अंदर की तरफ है. तो मैग्नेटिक इंडक्शन वेलोसिटी से मैग्नेटिक इंडक्शन की तरफ अगर हम फिंगर्स टर्न करेंगे तो ऊपर वाला डायरेक्शन हमको मिलता है. तो इसका मतलब जो फोर्स जो है तो वो फोर्स एक्चुअली अपवर्ड डायरेक्शन में उसके ऊपर लगने वाला है. ओके, तो इसका मतलब ये जो पार्टिकल है वो ऊपर की तरफ बेंड होने वाला है. सो लेट अस कंसीडर इट एट दिस टू इंटर इट एट दिस पॉइंट हियर. ओके, सो सपोज ये पार्टिकल जो है वो यहाँ पे इंटर करता है. तो सो दैट वी कैन जस्ट अंडरस्टैंड इट विल जस्ट बेंड इन द डायरेक्शन एंड वी वांट टू फाइंड द टाइम टेकन बाय इट टू ट्रेवल अ 90-degree आर्क. ओके, तो मतलब 90 डिग्री तक टर्न होने तक का उसका एंगल हमको ढूंढ के निकालना है. Okay, so it will just perform a circular motion as soon as it enters into the magnetic field and just will vary like this. So at some point it will just cover a 90-degree angle and we have to find out the time interval for that. For example, if you want to draw the diagram carefully, तो इस तरह से कुछ होगा वो. Yes, we can just show it here. Suppose the center of this circle will be at this point here, and it will start at this point. यहाँ से वो start करेगा, and it will just perform the circular motion and just complete the 90-degree angle here. Okay, यहाँ पे वो आके 90-degree angle उसका complete हो गया. देखो ठीक से. तो अगर ऐसा है तो उसमें हम देख सकते हैं आराम से कि ये जो पॉइंट है इसको अगर हम ज्वाइन करेंगे इसके साथ और इसी पॉइंट को अगर इसके साथ भी अगर ज्वाइन कर देंगे तो ये एंगल एक्चुअली 90 डिग्री बन गया. करेक्ट है. अगर ये एंगल 90 डिग्री है तो इसका मतलब वो क्वार्टर सर्कल बन गया. क्वार्टर सर्कल, अभी क्वार्टर सर्कल करने के लिए कितना टाइम लगता है तो उसमें हमको पता है ऑलरेडी. इट टेक्स अ टाइम ऑफ t/4 वेयर t इज कैपिटल T इज गोइंग टू बी द टाइम पीरियड. करेक्ट है. तो अगर हमको यहाँ पे टाइम पीरियड अगर 4 से डिवाइड करना होगा बस जरूर. जैसे हम इस टाइम पीरियड को 4 से डिवाइड कर देंगे तो हमको आंसर मिल जाएगा आराम से. ओके, दैट इज वी हैव टू डू हियर. सो t/4 विल बी एक्चुअली द आंसर. बट हाउ विल यू फाइंड इट आउट, हाउ विल यू फाइंड आउट टाइम पीरियड हियर. तो उसके लिए हमारे पास फॉर्मूला है जो कि हम जानते हैं ऑलरेडी कि अभी चलो रेडियस का फॉर्मूला तो हमारे पास ऑलरेडी है जो कि एक्चुअली mv/qb हुआ करता है. whenever a charged particle enters into the magnetic field, its radius is given by this formula. and period of revolution के लिए फॉर्मूला क्या है. period is given by 2 pi r upon v. This is the formula for circular motion, from circular motion. तो अगर circular motion के अंदर ये formula use करते हैं तो ये 2 pi by v will be kept as it is, and here r can actually be just replaced by this value here. तो ये r का जो वैल्यू है वो अगर हम यहाँ पे डाल के रख देते हैं तो उसमें हमको नेक्स्ट स्टेप में देखो क्या मिलेगा. So here you can just see that this v will actually be get cancelled, and what will be left with is 2 pi m upon qb. That's all. So this is actually going to be the formula for period, but we don't want the period. Actually, we want t by 4, right? So the required time, okay, which is taken by the particle to traverse a 90-degree angle. So that required time will actually be equal to t by 4. And t तो already मिला हुआ है, तो यहाँ पे इसको अगर 4 से डिवाइड कर देंगे तो क्या होगा देखो, तो वो बन जाएगा 1 by 4 times of 2 pi m upon qb. And if we just cancel out this 2 and 4 here, so that we can just be left with 2 in the denominator, so that we can get this pi m upon 2 qb as a final here. And now we have to put all the values here. So the time, required time here will actually be equal to pi, which is 3.14, we know that, into m, that is the mass of proton, which is already given there, that is 1.65 into 10 raised to minus 27 kilogram. No doubt, a unit is standard one only. Yes, and that is to be divided by 2 times of charge on the proton, which is same as the charge on electron, that is 1.6 into 10 raised to minus 19 here in this case. And B, that is the magnetic induction, which is already there, 100 millitesla. Okay, so 100 milli matlab 10 raised to minus 3. So 10 raised to 2 into 10 raised to minus 3 becomes actually 10 raised to minus 1 here. Note here that the velocity is given unnecessarily actually. Okay, यहाँ पे velocity देने की जरूरत ही नहीं थी. And if you just want to calculate this approximately, then this 1.6 and 1.6 can be cancelled straight away. And 3.14 divided by 2 comes out to be actually 1.57. Okay, into 10 raised to minus 27 and plus 20, which is minus 7 only. So here it will be 1.57 into 10 raised to minus 7. So 10 raised to minus 7 तो सबके अंदर है, but the most close answer is actually going to be 1.62 here, because we have approximated it here. Okay, यहाँ पे हमने approximation किया है, इसलिए उसकी वजह से थोड़ा आंसर जो है ज्यादा तो आएगा जरूर. And it will be actually 1.62 into 10 raised to minus 7 seconds. Okay, this is the time. Yes, let us see the next one. Let's see some questions from other competitive exams. See, here is 16th question here. It's very easy again. The magnetic flux is given by 5t cube minus 100t plus 300, right? And we want to find out the induced EMF at time t equal to 2 seconds. So you can just do it orally. If you just differentiate this phi here, then 300 का तो square root जो derivative है तो वो तो आराम से 0 बन जाएगा, और 5t cube का derivative आएगा 5 3 is 15, 15t square minus 100. And if you just put t equal to 2 here, 2 का square बनता है 4, and 15 into 4 is 60. 60 minus 100 is minus 40. So 40 will be the correct answer because minus sign is already there in this Faraday's law. Okay, तो Faraday's law के अंदर already minus sign है, इसलिए यहाँ पे 40 आंसर करेक्ट होगा. Yes, 17th वाला चेक करो. If the current of 3 ampere, okay, a current of 3 ampere is flowing in the primary coil. Okay, primary coil के अंदर 3 ampere का current flow हो रहा है suppose, and is made 0 in 0.1 seconds. The EMF induced in the secondary coil is 1.5 volt. The mutual inductance between the two coils is, we can just do it here only. See, the mutual inductance is to be found out. So mutual inductance के लिए formula क्या है हमारे पास? The EMF produced in secondary is actually going to be mutual inductance into the rate of change of current in the primary. ये formula हमारे पास है. Okay. तो यहाँ पे अगर म्यूचुअल इंडक्टेंस निकालना है तो EMF इन सेकेंडरी इज ऑलरेडी गिवन टू बी 1.5 वोल्ट. सो यहाँ पे हमने 1.5 डाल दिया. इधर म्यूचुअल इंडक्टेंस फाउंड करना है और करंट ऑफ 3 एम्पियर फ्लोइंग इन द प्राइमरी इज मेड 0 इन 0.1 सेकेंड्स. दैट मीन्स द चेंज इन करंट इज गोइंग टू बी 3 minus 0, मतलब 3 हियर, and it is made in time 0.1 seconds. So time is given to be 0.1 second here. So if we just solve this further, then we can get this 1.5 is equal to m into 30, right? So that m will actually be equal to 1.5 upon 30, which actually happens to be 15 upon 300, right? And what is 15 upon 300? 15 ones are 15 twos are 1 upon 20, which is 0.05. So it is going to be here first option as a correct option. Yes, 10th one here. The turns ratio of transformer is 2/3. If current through the primary is 3, does the calculate the current through the load resistance? मतलब secondary. Okay, so sorry. See here, turns ratio दिया हुआ है, मतलब ये NS to NP ये रेशियो होता है. Turns ratio याद रखो इससे हमेशा. The turns ratio means NS to NP ratio होता है. Yes, and if it is given to be 2:3 and current through primary is already given to be 3 ampere. So the current through secondary we want to find out. We know that this turns ratio, which is NS to NP, actually happens to be inverse ratio of current, matlab IP to IS, right? So NS to NP is given to be 2/3 and IS to IP, IP to IS. So IP is given to be 3 ampere here. So if we just put this 3 as here and IS is to be found out. So IS will actually be equal to 2 IS will be equal to 9. So IS will be 9/2, matlab 4.5, which is going to be there in this option 2 here. Okay. So the next one. Two inductors, each of inductance L, are joined in parallel. Then their equivalent inductance is. Okay, तो जब दो inductances parallel में join किए जाते हैं तो उनका equivalent inductance कितना बनता है? तो तुमको already पता है L/2 बनता है और क्या बनता है? Because you know that when their inductance are kept in parallel, so we have to use the formula 1 upon LP is equal to 1 upon L1 plus 1 upon L2. But since L1 and L2 is same here, so you can just say that 1 upon LP is actually going to be 1 upon L plus 1 upon L. So that 1 upon LP becomes equal to 2 upon LP, L, and hence LP actually becomes equal to L/2 as a final. Okay. Yes. Okay, so चलो ठीक है. So let us see some more questions in next lecture. नेक्स्ट लेक्चर में जो हम क्वेश्चंस करेंगे वो थोड़ा डिफिकल्ट रहेंगे. ठीक है, तो थोड़ा सा हम एडवांस लेवल के या थोड़ा सा और डिफिकल्ट क्वेश्चंस करेंगे. ठीक है, नेक्स्ट लेक्चर में, कल के लेक्चर में. ठीक है, सो कल मोस्ट प्रॉब्ली ये चैप्टर खत्म हो जाएगा. सो उसके बाद मतलब मंडे से हम नेक्स्ट चैप्टर स्टार्ट कर सकते हैं आराम से, दैट इज ऑल्टरनेटिंग करंट्स. ओके, सो जस्ट बी प्रिपेयर्ड. सो पढ़ते रहो, उसके अंदर के फॉर्मूले जो है वो रिवाइज करते रहो. ओके, सो चलो ठीक है.